Hello everyone, thanks for joining my channel Cloud and Coffee with Navneet. In today's video, we are diving into something really fascinating, the rise of large language model or LLM and how they changed the world. November 30th, 2022, the day everything's changed. That was the day when OpenAI launched ChatGPT, and what happened next was nothing short of mind-blowing. Within just 2 months, it became the fastest growing technology in history, hitting 100 million users faster than anything before. To put that into perspective, TikTok took 9 months to reach that milestone. Any guess how much time Instagram took it? Whopping 2.5 years. Yes, you are hearing right. Instagram took 2.5 years to reach 200 million users, whereas ChatGPT just reached within 2 months. But this wasn't just another viral app. ChatGPT didn't just change the game, it rewrote the entire rulebook. Suddenly, AI wasn't just something in sci-fi movie. It was helping people write code, do brainstorm, automate businesses, and revolutionize customer support. What exactly an LLM and why do we call it that? Where did it came from? To truly understand this breakthrough, we need to step back and ask a crucial question. Why is understanding languages so difficult for computer? And is more importantly, how do computers actually process text? To answer that, let's rewind and explore the fascinating history of natural language processing or NLP. For humans, understanding language is second nature. But for computer, it's incredibly complex. Unlike number, words can have a multiple meaning, change based on context, and follow no fixed pattern. Example, the bank is near the river and I deposited money in the bank. The same word bank has a different meaning in each sentences. How can a computer tell the difference? Early computers struggle with this, and simply keyword system based weren't enough. That's where the natural language processing or NLP comes into play. NLP helps computer break down and analyze human language in a structured way. But before we explain modern AI, let's take a quick trip back into the time and see how machines first started working with the text. Before computer can understand text, they need to break it down into small pieces, call it tokens. Example, word tokenization. This method breaks down a sentence into individual words. For example, the phrase unbelievable performance would be split into unbelievable and performance. This approach treats each word as a distinct unit, make it simple but sometimes inefficient for handling a rare or complex word. That's where serve-word tokenization or byte pair encoding or BEF comes into picture. Instead of splitting words into entirely, these techniques break down into meaningful serve-words component. For example, unbelievable might be segmented as an unbelievable. This approach helps handling both common words and unfamiliar words by recognizing meaningful. The third one is character tokenization. At the most granular level, this method breaks down a word into individual characters. For instance, unbelievable would be tokenized as U, N, B, E, L, I, E, V, A, B, L, E. While this allows model to handle any text, it significantly increases the sequence length, making training and inference more complex. Each of these tokenization methods has its own strength and trade-off, influencing how effective a model processes and understands language. But even with the tokenizations, there was still a major limitation. It treated words as a separate entity, without capturing their meaning or relationship. A computer could recognize that king and queen are different words, but it wouldn't understand how they are related. This posed a significant challenge in making machines truly comprehend language. To address this, researchers developed a revolutionary concept called word embedding. Instead of representing word as an isolated symbol, embedding maps them into a multi-dimensional space where similar words are placed closer to each other and based on their meaning. This allows model to grasp relation between words and even perform analogical reasoning. Consider the famous word vector relation: king, man, and woman, queen. This means that relationship between king and man is similar to the relationship between queen and woman. By using embedding, a model can infer such relationship, apply them to various language tasks, and leading to a deeper understanding of text. Embedding transforms the way AI processes language, make it possible for model to understand context, synonyms, and even nonsense meaning, laying the foundation of model NLP advancement. One of the earliest methods of NLP was bag of words, which treated sentence as just a collection of words. The problem? It completely ignored order and context. Example, the cat sat on the mat. The mat was sat on by the cat. For us, this sentence means the same thing, but for bag of words, they are completely different. And that's not all. It's failed when the same word have a different meaning, like bank, which is financial, and versus a river bank. Clearly, we need a smarter system. Then in 2013, a major breakthrough happened. Word2Vec. Word2Vec revolutionized NLP by learning relation between words instead of just counting them. It placed words into high dimension space where similar words were close together. Example, king is close to queen. Paris is close to France. Apple, which is fruit, versus Apple, which is a tech company. They are way different. This was a huge leap forward from back to words. But Word2Vec still struggled with long-range dependencies. It couldn't capture more meaningful beyond a few words. To truly understand context, we need something more powerful. And that's where the transformer changed everything. In 2017, researchers at Google introduced Transformer, an entirely new way for AI to process text. Unlike previous models that read text sequentially, Transformer used something called self-attention mechanism. So now let's understand what did this change. Parallel processing. No more reading word by word. Transformer processes the entire text at once. Better context understanding. They can recognize dependencies between words no matter how far apart. Last but not least, scalability. They paved the way for truly massive model. Transformer was so powerful that they didn't just improve NLP, they completely revolutionized it. Their impact was so profound that they paved the way for entire new generation of AI model. We call it large language model or LLMs. This model could understand, generate, and even reason with human language like never before. But not all LLMs function the same way. In fact, they came in different types, each designed with a unique strength and application. Let's break them down into three main categories. The first one is encoder-only model. They are best for understanding text. This BART, Robot A. The use cases around are search engine, sentiment analysis. Then we had a decoder-only model, best for generating text. That is GPT, GPT-2, ChatGPT, GPT-4, DeepSeek, etc. These models are widely used models. Example, you will be doing the chatbot, code generation, music generation, image generation, etc. And then we had the third model. The third one is encoder-decoder model, the best of both worlds. Example, T5, FLAN-T. The use cases around these models are translations, summarizations, etc. Now let's answer the big questions. Why do we call them large language models? The term large refers to two main things: the vast amount of training data and the massive number of parameters those models have. Training data size. These models trained on trillions of words from books, Wikipedia, news, and even conversations. The number of parameters. ChatGPT, which was launched in 2019, has 2.5 billion parameters. ChatGPT-3, which was launched in 2020, which has 175 billion model. ChatGPT-4, which was launched in 2023, which do not tell how much parameter they have, but it estimated it's going to be in trillion. Now we have a fair understanding around LLM and why we call them LLM. Let's understand where this technology is heading next. The next frontier is agentic AI. AI that doesn't just respond but act. Future LLM will be analyzing data, making decisions, and even taking autonomous actions. With multi-model AI, we are moving towards models that understand text, image, audio, and even video. So what do you think? Are we on the verge of the true AI intelligence? From the simple bag of words model to the rise of ChatGPT, the journey of AI has remarkable, but this is just a beginning. And if you're looking to learn more about AI and Gen AI in general, please like, subscribe, hit the notification bell for more such deep dive sessions. See you in the next one. Thank you.